We know we have a ton of people on the planet. We know we're using resources at a somewhat alarming pace. We know that the quality of food available, the nutrient density quality has gone down. We have to come up with something else.
Caleb Harper is a research scientist at MIT's Media Lab and the inventor of the food computer, a device he hopes will be a revolutionary new approach to agriculture.
The food computer is an idea about taking a greenhouse and then putting a computer on the side. And that computer has a brain. And so that brain can analyze what's going on inside of the little greenhouse and then make changes over time. The easiest way to think about it is we have the box, and imagine that Mexico climate is in that box. Whatever atmospheric conditions that grow really great strawberries. And you're like, I want this Mexican strawberry, but I live in Boston. So what we try to do is take the climate of Mexico, we record that, and we create a plant recipe. And think of it like a library full of books. You pull that digital book down, you load it into the software, and no matter where you are in the world, that climate begins again.
I went to visit Caleb at MIT and get inside, both figuratively and literally, the food computer.
So this world is perfect for the plants, right? We're in plant heaven right now.
Right.
These plants are getting all of the good kind of light that they need. They're getting access to water all the time. Plants like to be stable.
Sure.
When the environment changes, the plant also reacts, and it's like, oh my gosh, what's coming next? I'm gonna shut down.
Yeah.
And I'm gonna shut down until the climate gets good again, and I'm gonna start growing again.
Right.
So in here, it's like pedal to the metal.
So from here to here in
Yep.
2 weeks
Right.
is, I'd imagine, faster than
Yeah.
the natural world.
Yeah.
Is that fair to say?
Totally. So this method is running anywhere between 3 and 4 times faster. A head of lettuce that might take us 60 to 90 days, maybe we're getting in 15 to 17 days.
Right.
Growing a lot faster, using a lot less resource, because when we use water in that lab, it's constantly recirculating. We don't lose any to groundwater, we don't lose any to surface runoff, so we can get into using between 50 and 70% less water than conventional farming. We're using this technique, which is aeroponics, right? So if you get down here, right? So there's no soil and there's no standing water. And what happens is just mist fills this box.
In addition to using fewer natural resources, the food computer also consolidates the supply chain. Growing food in the same place you're eating food is better by really any metric. It means that food doesn't lose nutrients during the packaging and preserving process. It means price tags don't need to account for all that costly shipping. And perhaps most importantly, it eliminates the environmental impact caused by transporting food all across the world.
So we're sending our food these long distances. They're getting less nutrient availability along that supply chain, and they're producing carbon emission. My job, or my vision, is to take that world and replace it with little wireless signals. Like, I'm sending you a climate recipe, you're on the other side receiving it, and you're able to produce the exact same food that I can.
The idea for the food computer was inspired by a trip Caleb took to Japan shortly after the Fukushima disaster. What he saw was a land devastated by both environmental and nuclear contamination, as well as a population genuinely afraid of the food being grown there. He became convinced there had to be a better way to control the process of food production.
After that experience, I got home to the lab, created a funny little box, and I killed everything. So I started asking people for help. I put out a bulletin for students, and I said, do you want to build the real Farmville? And I got a ton of response, bunch of young students, because they're all interested in food now.
Let's just pop
Let's
that,
just
let's
rip it
pop
off.
that off,
Yeah.
and then we'll just probe directly to it.
Cool.
So the food computer really sits kind of halfway between super complex and really actually pretty simple. The concept and potential impact is huge and massive. It involves a convergence of factors, but the component parts are really simple. They're ordered on Amazon and bought at Bed Bath & Beyond and rigged together by some kids. It's truly a perfect example of the whole being greater than the sum of its parts.
We've probably built 10 different versions of the food computer in 2 or 3 months. And so right now I have basically a shop full of elves. I am one of the elves, and we are building these machines out because if we tried to wait for someone else to do it, right, it would take forever. So we have a little factory turned on. We're building these things, we're putting them out, and we're testing them.
We just got through testing all the actuators.
Okay.
So like turning on the humidifier
Yeah.
and all that.
Oh, look at that.
It's,
Gotta love things with LEDs.
Yep.
There are 3 big food computers we call food server, about the size of a shipping container farm. There's one here in the Media Lab, there's one in Guadalajara, Mexico, and there's one in East Lansing, Michigan. The smaller personal food computer I just put out this week, so it's the first time the world's seen it. There are about 6 of them existing in local schools in Boston, grades 7 through 12.
We're here at Charlestown Public High School outside of Mr. Hayes' science class, where Caleb is teaching a whole group of high school students about food computers.
Essentially, think of this as a greenhouse and this as a computer. So it's a computer-controlled greenhouse. We call it a food computer. This is just something that our team's been working on for a little while, and we